right, welcome back. We're going to get right into networking. We've been covered a lot of things in the earlier courses on virtualization, hardware, software. Now let's look at the lower layers of this information system, networking. All right, let's do this. So when we talk about networking, I always like to start out with probably the most boring subject ever is architecture and architectural models. And we call these, you probably heard of the OSI model. But models are very important. These models really, why? It helps us to be able to explain and architect and describe networks, as well as understand how to secure them at these individual layers. So when we think about a model, that's this. It's a common language that will help describe a network, and it really is. It's a very powerful tool for being able to diagnose problems within a network or within your environment. The model that I enjoy teaching from is this. This is the 7-layer open system interconnection, or OSI model. So what it has, and for the purpose of this information systems management course, not going very deep into this like I do when I normally would build a course or teach a course for cybersecurity or for networking. But basically you have layers. Everything is built in layers, from the layers 1 all the way to layer 7. And it's what it's showing is how one computer across the network, across the internet, is able to talk to another computer from one layer to another. So the application layer is able to talk to of a sending machine is able to talk to the application layer of the receiving machine, all the way across. And each of these layers do different things, from the application, the presentation, session, transport, network, your data link, and your physical layer. So when we think about these layers, these upper layers, your layer 7, layer 6, and layer 5, as well as most of layer 4, they reside in the operating system. And we talked to operating systems earlier. But these are the ones that actually get your data. So if you're let's say going back to that Word document, that's at the application layer that you're writing that Word document. And really, these layers are talking about protocols. And when you hear the word protocol, just think of a protocol as a way of talking to each other. If we speak English, that's the protocol that we speak. If I speak Spanish, I'm changing the protocol because we're speaking, a different language. So the protocol is how computers are able to talk and understand each other across the network. It says, well, that's what a protocol is. So if you look at these various protocols, HTTP, HTTPS, those are the things that's required for two systems, two endpoints to be able to talk across the internet. But so that is what basically a model, the 7-layer model is. And there are many little jingles out there that you can use to remember these layers. All people seem to need data processing. That's just happened to be one that I remembered from years ago. But there's one that deals with pizza or something. I don't remember that one. Now, this is a great model for teaching from an academic perspective. However, day to day, the TCP/IP model is what you're going to see used more often. And what all that TCP/IP model does, it takes the 7 layers, same 7 layers, and it breaks up out and packages them into 4 layers. So I say the first 3 layers, your application, presentation, and session layer, they become the application layer and the TCP/IP. Transport remains transport. Layer 3, which is your network layer, that becomes the internet, and layer 1, layer 2 is your link layer. So this is as deep as I can say. I'm going to go into network architecture as far as the OSI model. Now, I will tell you, I have other courses out there that goes much deeper if you so desire to go deeper into these models. The reason I'm going to bring this up because the next thing we're going to talk about is going to deal specifically with the last 3 layers. Layer 1, layer 2, and layer 3. This is really where most of your networking happens. Layer 1 at the physical layer, which is your cable, your fiber optic, wireless. Layer 2, the data link layer. This is where you do your physical addressing with MAC addresses and those things. Ethernet, you probably heard Ethernet. It lives at that layer. Or layer 3 is where you're routing, your IP addresses and all those things. They live at the layer 3. So for the purpose here, we're just going to focus on those last 3, the bottom 3 layers. Now, when we think about your network, a lot of devices, a lot of hardware that lives at this layer. Some things that you're going to be aware of, need to be aware of this layer is, your layer 3 routers, layer 2 switches. These are what your firewall appliances look like, as well as Wi-Fi routers. I'm sure most of us have Wi-Fi routers in our home, but again, in larger networks, likewise, you have Wi-Fi routing capabilities. But that's just a snapshot of what these different devices look like. All right, so now let's do this analogy, what I call the USPS postal system analogy. Why do I call it that? Because the network, the internet, all these things we use today was they were started back in the 70s, right? And the model that was available in the 70s for moving information, whether it was letters or whatever it was at the time, was the U.S. postal system. So you see the internet that we use today, the network structure we use today, was built on the U.S. postal systems. That's why we have email, we have routers, we have hubs, all of this terminology. You can kind of see the similarities. All right, so this is a fictitious analogy, fun but fictitious, that I use to help hopefully better describe what is going on the network at these layers. All right, I live in Dallas, Texas, right? This is my house, 111 Nate Street, Dallas, Texas, zip code 75023. My grandmother, who I love very much, dear lady, she lives here in Dallas also. She lives at 225 Penny Avenue, which is just a couple of streets down. Because you see our zip codes are the same. She's also 75023. Now, my grandmother, she didn't grow up in the internet and the email era, so she likes to get letters. So I still like to write her letters. So I try to at least once every 2 weeks, write a letter. Now, what I do, well, like we all know, there's a protocol, going back to that word protocol, that the U.S. Postal System established on how to set up an envelope so that they can properly move your mail throughout their distribution system. And if you're aware of that, the source address, or we call it return address and with a letter, that's my address. The destination address, that's my grandmother's. And of course, you got to put that little stamp right there in the corner, otherwise it's not going anywhere. So that is the protocol to send a letter, okay? Now, I will say that is analogous to how we use IP addresses within the internet. This is how we're able to move things on a network with IP addresses, and it's very similar. Now, we use what we call today, we're IPv4, and we're moving to Internet Protocol version 6. So basically, instead of having these down, you got to remember, we're talking about binary numbers. 1 and a 0. When we think about how we move data, digital data, it's all ones and zeros. So a IPv4 address is 32 bits. 32 bits means that there are a combination of 32 ones and zeros in that IP address. So that's all well and good, right? Now, if you ask me my physical address, I can rattle that off pretty quickly. Yeah, I live at 111 Nate Street, Garland, Texas, 75023. If you asked me my IP address on my computer, and I had to use the same vernacular, I would go 110000000000000000001000000010000000111. You got that, right? Yes, very difficult, very confusing. So what we do with IP addresses, we take those 32 bits and we break them up into 4 octets. Yeah, 4 octets. Octal, think octal, like an octagon, 8. 4 sets of 8. So now, instead of having to remember 32, now we got 4 sets of 8. So the first group of 8 is 1100000. Now we do a little thing called binary to decimal conversion. Not going to get into that here. Again, I got some other training that will help you walk through that. But we're going to convert that binary number to a decimal number, and it comes out to be, I've already done the math for you, 192. The next octet of 8 is 10101000. I do the conversion of that is 168. Octet number 3, which is all zeros in the last one, translates to 1. And here's octet number 4, and that translates to 15. So now, instead of having to quote that 32-bit, I can now use it, have it in a format that's a little easier to translate, what we call dotted decimal, 192.168.1.15. Now, you've probably heard that before, right? You probably never knew what it really meant. Maybe you did, maybe you didn't. But that's where that comes from. That is how we now are able to know what the source address and the destination address. So if they ask, well, what's the IP address of your computer? 192.168.10.3. Much easier way for us humans. Okay, so addressing, and this is the protocol that we use to do digital addressing. But anyway, back to my grandmother and our letter. So I've got the envelope addressed. I got the letter in there. I put a little perfume on there because she likes that. And now I'm ready to go drop it in the mailbox. I put it in the mailbox, and guess what happens? A little truck with a red stripe comes by, and that individual in that truck picks up my letter and takes it to the local post office that's about two blocks away. Now, that is analogous to layer one, the physical layer. Meaning that truck across the highway, he's just getting raw information from point A to point B. The same way cable, fiber optic, Wi-Fi, your copper cable, it is just a transport. It is just a means of moving information, ones and zeros, from one place to another. So they got my letter to the post office. Now something interesting happens. And it's so funny when I teach this, I find out that most people don't even know how our own postal system works anymore because we don't write letters anymore. Well, what do? They get to the post office and they look at the zip code, the Zone Improvement Plan. That's what ZIP stands for, by the way. When years ago, I remember when we didn't have zip codes, but now as the population grew and cities grew, they had to come up with a way of better managing mail traffic. So they set up zones. And that's what these zones are. Our zone is 75043. Well, anyway, so they look at the zip code and they go, you know what? Both of these addresses have the same zip code. So that is a local delivery. So they take my letter, they put it in another little cubby that goes into and maybe even the same mail driver. But anyway, a driver in the same area, and he takes that straight to my grandmother's house. So that was a local area delivery, or a LAN. Local area network. That's what layer 2 of your network does. So in your home, you probably have a routing device. Well, guess what? All of your devices that connect, whether they're wired or wireless, are a part of that network. And they are a part of your local network in your house. Now, I can't see your printer in your house unless you give me access to it, through some type of routing capability, because those devices are local. As a matter of fact, you could lose internet access and you could still print on your printer. Why? Because your printer and your computer are connected via this switch routing device, the switch that you have in your home. Local area. So that's what we've just created, is a LAN, a local area network. It went from my house to the local post office that acts like the switch, and they took it right there. And my grandmother got the letter, and she is so happy. Well, something happened along the way, and my grandmother decided to move to Cali. That's right. She's going back to Cali. And when she did that, she went to her address changed, as well as, you see, her zip code. Her zip code changed. She is no longer a 75023. She is now 90210. So, but I still want to write her. So how do they get the letter there? Same thing. I mail the letter to our local post office. The local post office looks at the zip codes now, and they go, whoa, wait a minute. This is coming from 75023. I recognize that. But it's going to 90210. And the local post office don't know how to get that directly there. So what do? They put that on a mail bag, put it on a plane, and they send it to St. Louis. St. Louis, this is where we have a postal hub. And St. Louis, as a postal hub, knows how to route mail all over the United States because it knows where all the zip codes are. So, and it does the same thing. It looks at the zip code and says, oh, this letter is going to 90210. I know exactly where that is. That is in Los Angeles. So they put it on another plane, and they send it to a local post office in San Bernardino, close to where my grandmother lives. Then they look at it and go, oh, 90210, yes, I know where that goes, and that mail gets delivered to my grandmother's house. So now I've used St. Louis as a layer 3 device because it is able to route. So that's what routing is. So in our network, the same thing. Routers are layer 3 devices that are used to connect disparate LANs. So you see I have a local network here in Dallas, and I have a local network here in California. However, to get these two local networks to talk, these two LANs to talk to each other, I have to have a layer 3 device in the middle that is able to connect these two local area networks together. So that is how our traffic, email, whatever it may be, is able to move across the internet because we have the ability to do routing. Or if you're inside of an organization, you have routers because this could be finance and this could be sales. They could both be on their own local area network, and they are unable to talk to each other in the same building without a layer 3 device, a router that is able to route between those two local area networks. So you see, I think how now we're building security in, because if I don't want these two to talk to each other, now I can just change my routing schema so that these two networks can't talk to each other and set up some types of security. But yeah, so that is how the network actually works from a layer 1 physical layer, layer 2, which is your data link layer, with your switches, and layer 3, which is your routing layer, IP addresses, and being able to route between local area networks. So when we think about a basic network architecture, right? Think about the components we had before. So in an organization, how do we build up a network? Many times as we look at this, let's start at the bottom with our user devices. These are all of the computers in your, say in your organization. So then what we do, all those computers connect up to a layer 2 switch, layer 2 devices. Many times you'll see these in the individual rooms, or if you're in your organization, you may walk in and they have closets where these switches are connected. But anyway, you'll see that this is how all the computers connects back to these access switches. And the access switches many times are aggregated up to a higher level switch or a distribution switch that provides those two local area networks. Now I have local area network 1 and I have local area network 2. Now as you see, these two local area networks cannot talk to each other. So if Charlie, who works over here, wanted to send an email to Susan, who works over here, that's an impossibility because currently those two, they are on separate local area networks. How do we fix that problem? You got it. We put a layer 3 device in the middle. It can be a router or a layer 3 switch. And now I'm able to route traffic from LAN 2 over through the router, through the layer 3 to LAN 1. So now these individuals are able to talk to each other. Well, that's all well and good. What if I wanted to get somewhere else? Let's say out to the internet. Well, we can do that also. And now this is where that firewall appliance comes in, because we don't trust anything on the internet. So we want to be sure that we have firewall rules set up so that just not any traffic can come through here and get to our network. Likewise, we don't want people surfing porn, or we don't want people, hitting gambling sites. So we can set up firewall rules here to where you would not be able to get to those sites. That request would be blocked. So that's what kind of a basic network architecture looks like, from a local area network, a wide area network when I connect these together, and then access to external services, out to the internet. Now, something else we like to do in this environment is what we call a DMZ, a demilitarized zone. Now, what is that? Well, let's say that, we work with other industry partners. We call them competimates sometimes, because we are competitors, but at the same time, we're teammates. But anyway, we don't want them to have access to our secret sauce down here. So we have an area, like a DMZ, and that comes from, the Korean War, DMZ, where we have a demilitarized zone between North Korea and South Korea. And that's like there's no activity, no action going on in that demilitarized zone. So same thing here. So now you can put file servers, you can put things in this DMZ where someone from outside the network can get to it, someone internally from the network can get to it. However, it keeps people from the outside that you don't want being able to get directly into your internal network. So so a lot of times, you'll put maybe your company public-facing website maybe sitting here. That way, if you're working from home, you can still get to your company's public-facing website. However, they may not want you coming all the way in. So just, or your HR department may have job recs sitting out here because they still want people to be able to get there and who want to apply for a job or whatever. However, they don't want them to be able to get into your network. So that's why we put those things in a DMZ, a demilitarized zone. All right, so we covered a lot of things in this particular session. We covered components of computers. We talked about cloud computing, virtualization, mass storage. We just finished up with networking. A lot of concepts. Like I say, and still a lot deeper we could go in these areas. However, with respect to information systems management, we just wanted to kind of stay at the 10,000 foot level, not really the 50,000 and not at the 10-foot level. I hope this helps a lot. Stay tuned. We're going to take you into another course as we continue our presentations on information systems management.